Okay, let's look at balancing redox reactions using change in oxidation state for acidic solutions. As we said before, the first step is to establish our change in oxidation number. So we've got permanganate ion reacting with a sulfide ion, S2-, to give us manganese 2+ and sulfur in its elemental form. So if we look at our oxidation numbers, the oxygen will have a -2, therefore our manganese must have a +1. And our sulfide it's -2 as an ion, therefore must have an oxidation state of -2. Our manganese 2+ will have +2 and our sulfur will have 0. So we can write these into our table. We've got manganese and sulfur. Our manganese initial oxidation state is +7, going to a final oxidation state of +2. Our sulfide, on the other hand, is going from -2 to sulfur being 0. So if we look at our reduction component, we're going from +7 to +2, therefore we're gaining 5 electrons. And our sulfur is going from -2 to 0, therefore it's losing 2 electrons. We then look at the number of atoms in the original reaction. Manganese, we've got 1 and 1, so we write down 1 atom. Our sulfur, we go from 1 to 1, so we write down 1 atom. And we now look at the net transfer of electrons from our two components. So our manganese going from +7 to +2 is gaining 5 electrons. Our sulfur going from -2 to 0 is losing 2 electrons. So we have to look at a lowest common multiple to balance these two components. To go from the lowest common multiple of 2 and 5 is 10. So we need to multiply through the first reaction by 2 and the second reaction by 5 to give us 10 electrons in total. So we look at the first step. We've done our balance of electrons now. We need to do the same thing with our atoms. So we rewrite our equation, but this time we put in the multiples that we've worked out here. So we will find out that we've got 2 lots of manganese, therefore we put a prefix of 2 before the permanganate ion. We also put the 2 before the manganese 2+ ion as well. And we do exactly the same thing with the sulfur. We've got 5 lots of sulfide to give us 5 lots of sulfur in our reaction. So we're okay, we've balanced for every other atom except hydrogen and oxygen now. Step number 3 says that we need to balance our oxygen atoms, and we do that by adding water molecules to the system. So in our original reaction, we have 2 times 4 oxygens over here, which gives us 8 oxygens, and we have none on the right hand side, so we need to add 8 water molecules to this side. Problem is that we've now got an imbalance of hydrogen. We've got 16 hydrogens here, so we need to put 16 hydrogens on the other side, and we do that in the form of H+ ions. So our final reaction is 16 hydrogen ions plus 2 lots of permanganate plus 5 lots of sulfide ions gives us 2 manganese 2+ plus 5 sulfur atoms plus 8 water. Let's check if we got it right. And we do that both in terms of conservation of atoms or mass and in conservation of charge. So our manganese, we have 2 on the left hand side, 2 on the right hand side. Our sulfur, we have 5 on the left hand side, 5 on the right hand side. Oxygen, we now have 8 on the left hand side, we have 8 on the right hand side. Hydrogen, we have 16 on the left hand side, 16 on the right hand side. Finally our charge, we have 16 times 1, which is 16, minus 2, which is 14, minus 10, which is +4 overall. And on the right hand side, we've got 2 times 2+, which is +4. So that's now balanced.